Our course title is Advanced Enzymology. It includes generally the basic natures of what is enzymes, how enzyme works, what is the specificity, what is the enzymology, and how the enzyme engineering works in our life. So, starting with the unit 1 to 4 is including this advanced enzymology 2 plus 1, 2 theory plus 1 practical. So first chapters include enzyme catalysis and specificity. As I said in the previous, what is enzyme? Enzyme is a catalyst. Not simply your enzyme is a biocatalyst. How its specificity? What are the specificity? For these are the point 1, 1.1 to 1.7, including this unit 1. So first of all, we will understand the theory of enzyme catalysis, in which you will find enzyme plus substrate that will include enzyme substrate complex K1 and K2, and how it is product form, what are the mechanism involved in specific city of that. As I see, two important theory, induced fit and lock and key model, that will also comes in this Michaelis-Menten equation that in next chapter, mechanism of enzyme actions. So concept of specificity and editing mechanism. So nowadays, industrially, they are producing different kinds of industrial enzymes. They are edited enzymes can you have a speed up the reactions. So now editing mechanisms is very important concept to understand the enzyme catalysis and specificity, through which you can produce a number of things, fermented product, or you can produce a number of biocatalysts which are useful for pharmaceutical products. It has a bioengineering also. You can retard or detect a certain antibody antigen reactions. You can also produce a number of pharmaceutical product if the person is susceptible with specific disease. How we can engineer or editate that particular portions and attach or work on that enzymes, that can possible with this specificity and enzyme mechanisms. Then after concept of active site and enzyme substrate complex, that we already understand in the Biochem 2.1 at UG level as well as in the fundamental of biochemistry. Then after we also studied in the MSc course, huh, that basic biochemistry. They have given numerous active sites, a site at which the enzyme binds and it works efficiently. So site other than that also a concept of active sites that I will teach you how the structurally integrity with that enzyme substrate complex. And still to date we are not understanding how the mapping of active site can be possible. That I will give you an explanation how the active site mapping is possible in the enzymology and what is the concept behind that. We will understand in the enzyme catalysis and specificity and factor associated with catalytic efficiency. Still to date, we are only understanding factor affecting enzyme activity (pH). Then we are understanding substrate concentration, enzyme concentration, regulatory enzyme, allosteric enzyme, certain inhibitors. Now we will understand how the pH is affecting, how the temperature is affecting, what are the how you can measuring whether it is work at efficiently at specific substrate or specific concentration. So factor associated with the catalytic efficiency we will understand. Then as I said, Michaelis mental mechanism of enzyme actions and reactions. Finally, we will understand how the various instrument and various pathways can detect it and which are the mechanism to understand the intermediate metabolisms or intermediate enzymatic reactions that can form from substrate to end product, and intermediately it is utilized various pathways. Then after, very important unit for we as well as all enzymologists, or it works in how the kinetic energy works for understanding moving or rate of reactions, whether velocity of the reaction, substrate concentration, how it is worked, competitive inhibitor, non-competitive inhibitor, how it one VMX, one up, that we will study in the transition state theory, and very important reactions. Arrhenius equation is very important to understand enzyme kinetics. Then we will determine the energy of activations. The concept of energy of activation or determination of the energy of activations. As I said in the previous chapter, enzyme catalysis, during that also I have explained in 1.5 factor associated with the catalytic efficiency. Same is here also, enzyme in enzyme kinetics. You will understand effect of pH, effect of temperature, optimum pH, optimum temperature, how it's work, and if it is not, whether the temperature lower down, what will happen to the that particular enzymatic reactions. That I will show you with the example and practically also. This 2.4 is important for practical point of view also. I will explain all the enzymes which are in our course. Then in kinetics of enzymes, enzyme kinetics, the two things you have to understand. And I will explain in that chapter pre-steady state and steady state kinetics. Then SS kinetics, single substrate kinetics. Lastly, we will understand how this mechanism can be controlled, or number of enzyme it is in complex form, allosteric enzyme activities, and how the mix inhibitor works on that we will understand. So substrate concentration, product concentration, substrate inhibition or product inhibition, we will understand. And finally, I will give you in this unit 2 enzyme kinetics, there are certain example also with some with the equations. Then unit 3, you have already studied that, but this unit 3 is important for radioisotopic techniques or enzyme regulations or regulation of metabolisms, or two important things. You can give the more number of seminar on these topics, 3.1 to 3.6. Many people are unaware of this concept. So, so in mechanism determinations, enzyme mechanisms and regulation we have already understand, but in unit 3, that mechanism determination by radioisotope exchange. So which are the radioisotope are involved in the mechanism determination in the enzyme and its regulations, that I will teach you. Then what are the rules of enzyme in regulation of the metabolism, that we will understand in the mechanism and regulation. Now important, very important point of view, that is bifunctional enzymes. Still to date we are understanding they are giving only a one product. If fermentation is there, alcohol is giving. Now I am giving you one of more concept, bifunctional enzymes. That concept I will teach you and how it is useful in the day-to-day life as well as in these living systems. Pseudo-enzymes. Now I am giving you another term, pseudo. Pseudo means it is not properly, you cannot say that it is enzymes. But not like these. I will explain how the pseudo-enzyme and enzyme promiscuity. Loudly speak. Enzyme promiscuity. You can give the enzyme promiscuity with n number of seminar. Advanced enzymology. Therefore, it is. And these terminology, enzyme promiscuity, is very important in this chapter. Then another enzymes. अब मैंने पहले I have already explained that lower downwards pseudo enzyme, false enzyme you can say. Then I have bifunctional enzyme. Then enzyme promiscuity. Now I am giving you extremo enzymes. Extreme condition, extremo enzymes. Not like these. I will explain you what is extremo enzymes. Whether it is found in the aliphates or how it works. Catalytic nucleic acids. It is a very important topic for this enzyme mechanism and regulations. Ribozymes, catalytic DNA. How the nucleic acid is formed. How the nucleic acid center sequence is, what is happening in that. How DNA to mRNA, mRNA to protein synthesis, and what are the enzymes are involved in this nucleic acid synthesis. That I will explain you catalytic nucleic acids and its role in the enzymology, and how you can make a transgenic, how the Mars is related with that. Okay. Then very important for food process engineer, biochemist, industrial use, all industrial use, generally all the industrial enzymology include what are the advantages and disadvantages of biocatalysis, techniques, various technique driven processes, then how it is stabilized, regeneration of enzyme systems which are used in the biotechnology, how we can help the biotechnologies to stabilization or regeneration of the enzyme system. Yes, very important things nowadays. There are peptides which are useful, antimicrobial peptides are there. How these work? That can only be understood with the protein engineering. For protein engineering of enzymes, you require certain bioinformatics tools to understand these also. That I will explain you industrial enzymology. In this chapter, I will include previous unit 3 also. Bifunctional enzymes. Immobilization of enzyme. It is a very important topic. Then creation of chimeric. Interesting topic of enzymology. Semi-synthetic enzyme. As I said previously, what is pseudo-enzyme? Here one more terminology, semi-synthetic enzymes. They are used as a industrial biocatalysts. Semi-synthetic, not purely. Word itself indicate. But their practical significance I will explain. Modern information technology which are useful in the enzyme engineering. So this course is very important to understand the whole living systems as well as a biochemist, as a plant breeders or any life sciences scientist must know the advanced enzymology. Otherwise, their knowledge create a problem to these universals.